Welcome to the third unit in our atomic unit. Here we're tackling subatomic particles and their corresponding subatomic or atomic quantities. First of all, there are three subatomic particles. Subatomic, of course, refers to that which belongs to the atom. There are three of them. Protons, neutrons, and electrons. Protons, neutrons, and electrons. In terms of where we find them, protons and neutrons are found in the center of the atom, in a place called the nucleus. So both are in the nucleus, nuclear particles. Sometimes they're even referred to as nucleons, particles of the nucleus. Electrons, therefore, are outside of the nucleus. I'm going to say where they're located, or where they're probably located. I'll say more about that later. I'm going to give you a fuller definition of this in a future lesson in what we call orbitals. But I want to stress to you right now that I said orbitals, not in orbits. Right as we speak, our sun is being orbited by the Earth. But that's a two-dimensional path, and we know where the Earth is 100% of the time. The same is not true of an orbital. I'll say more about that later on. But electrons are not, strictly speaking, orbiting. Protons and neutrons have a very similar mass. We call that mass an atomic mass unit, AMU, or just U. They're both approximately one atomic mass unit. Those are relative units, by the way. I'm going to say two things about the electron. We simplify and say that the electron has a mass of 0, but I put an asterisk because asterisk means, well, it really does have some mass. It's actually a tiny fraction of the mass of a proton. How small? 1/186th, hard to say, of the mass of a proton, of a proton's mass. Meaning, if you wanted to get the equivalent mass of electrons for one proton, you would need approximately 2,000 electrons in mass to equal the mass of one proton. Well, actually, the mass of 2,000 electrons would be slightly greater than the mass of one proton. Charges. Well, protons are positive. Electrons are the negative particles. Now, when we say charge, there are two components of a charge. One is the sign of the charge. We also have the magnitude. This has a charge of +1. This has a charge of -1. Of course, neutrons, as their name implies, are neutral. They are uncharged. They have a charge of 0. Okay. Sorry. Okay, sorry, I lost where my pause button was. Okay, anyway. Off and running again. There are 4 atomic quantities that I want to go through with you. Atomic number, the nuclear charge, the mass number, and the overall charge, and let me add this, on the atom, or on the ion. I'll distinguish between those two terms in a moment. First off, atomic number is simply equal to the number of protons present in an atom. And what identifies an atom, what distinguishes, let's say, calcium from carbon from uranium, is the number of protons. Calcium has an atomic number of 20, copper 6, uranium of 92. It's like the Social Security number of an element. If you were to remove one of calcium's protons, well, I'm sorry, you don't have calcium anymore. You now have something called potassium. Therefore, calcium with an atomic number of 20 very simply has 20 protons. It's that easy. Now, if you know the number of protons, you know the number of positive charges in the nucleus, and therefore you know the nuclear charge, Also, it can be expressed as the charge on the nucleus. Sometimes students are surprised to see it put this way when they're used to seeing it this way. They're identical to each other. And that's simply going to be equal to the quantity of the nuclear charge. I'm sorry, the quantity of protons. Of course, it's the quantity of protons with a positive sign. So when I express calcium's nuclear charge, calcium has a positive 20 nuclear charge. You need to include the positive because charges are either positive or negative. Now, mass number and overall charge are both simple calculations. The mass number is a sum of the two subatomic particles that have significant mass. The mass of the protons, if I know the number of protons, and the number of neutrons, I know the mass number. For example, let's say that a calcium has, well, it has to have 20 protons, being calcium. But let's say that it has 22 neutrons. Well, what is the mass number in atomic mass units? Well, mass is equal to the number of protons plus the number of neutrons. So very simply, the mass number is 42 atomic mass units. It's that simple, really. By comparison, well, let me take a step back. When I ask about the mass number, I am looking at the particles that have mass, protons and neutrons. If I'm looking at the overall charge of the whole atom, I'm going to look at the subatomic particles that are charged. I'm going to look at protons and electrons. But whereas I added the protons and neutrons to get the mass number, to get the overall charge, I take the difference. From the number of protons, I'm going to subtract the number of electrons. Let me give you a concrete example. Let's say that our calcium, with its 20 protons, also has a complement of 18 electrons. Well, what's the overall charge on this particular calcium? Well, the overall charge is equal to the number of protons, 20, minus the number of electrons, 18. So that means on the entire atom, there are a total, the total charge is a positive 2. I caught myself, I was getting ahead of myself. I was thinking this way. Students confuse overall charge and nuclear charge. But remember, when we talk about the nuclear charge, we're talking about the nucleus. Since I have 20 protons in the nucleus, that means the charge on the nucleus itself is positive 20. Now, if I look in the shells outside of the nucleus, I have electrons. And I have a total of 18 electrons out here. So it means outside I have a charge of negative 18, but inside the nucleus I have a charge of positive 20. Well, that means when I neutralize, in a sense, the positive charges with the negative charges, once I use up all of my negative charges, I still have positive 2 protons not neutralized. So it's the difference between the positive 20 from the protons and the negative 18 from the electrons, leaving positive 2. In other words, you can think of it this way. There are still an excess of positive 2 charges that were left over after the other positive charges were neutralized by these 18 electrons. Okay. Final point. Actually, 2 final points. One thing that I want to, since we're talking about overall charge, when we use the word atom, this is a little bit confusing, but if I just use the word atom, an atom itself refers to an atom that is a neutral. If you are neutral, if you're an atom, meaning if you're a neutral atom, you are neutral for this reason. You're neutral because in your atom, the number of protons are equal to the number of electrons. They scientists wanted to create a name of a particle that, or in which, or for which this was not true. What do you call an atom, in other words, when the number of protons is not equal to the number of electrons? Well, we refer to it in that case as an ion, meaning an atom that is not neutral. If you are not a neutral atom, that means you're either positive in charge or negative in charge. In this particular case, the calcium was a positive 2 because in this situation, the number of protons in the atom is greater than the number of electrons. Of course, you can have the other situation where the number of electrons is greater than the number of protons. We'll say a lot about that over the course of the year. The last piece of information is isotopic notation. And this is just a way of symbolizing the three main atomic quantities in a very efficient way. So instead of saying, spelling this out, instead of saying calcium, this calcium has a mass of 42, an atomic number of 20, and an overall charge of positive 2, I place the mass in the upper left-hand corner, I put the atomic number in the lower left-hand corner, and I put the overall charge in the upper right-hand corner. Again, I can't stress this enough. The overall charge on the atom, or specifically of the ion, since it's a charged atom, is put in the upper right-hand corner. This is not the nuclear charge. Remember, if you wanted to know the nuclear charge, you would look at the atomic number, which is placed in the lower left-hand corner. Remember, the atomic number tells you the number of protons, and since it tells you the number of protons, it's telling you the number of positive charges. It's telling you the nuclear charge on the atom. Again, if you have 20 protons, you have a nuclear charge of positive 20. Again, in contradistinction to the positive 2 overall charge on the entire ion. And as I said, I place the mass number always in the upper left-hand corner. So it's just a very efficient way of doing this, of showing these atomic quantities. I have a little time left in my allotted time in the video, so why don't we interpret this isotopic notation? Well, this is saying that this oxygen has a mass number of 18. It has an atomic number of 8, and it has an overall charge of negative 2. So what if I wanted to say, figure out how many protons, neutrons, and electrons there were in this particular atom? Well, the number of protons is easy. Remember, it's just the atomic number. There are 8 protons. Now, the number of neutrons, we use this little expression here, this little formula. Mass equals protons plus neutrons. This is the mass number of 18. So 18 equals the number of protons 8 plus x. There therefore are 10 neutrons. Finally, how many electrons are there? Well, we can find out the number of electrons using the other little formula we have at our disposal. Overall charge equals protons minus electrons. We see that the overall charge is negative 2. Again, we have 8 protons, and we're going to solve for the number of electrons. If I subtract 8 from both sides, I get a negative 10 equals a negative x. In other words, x equals 10. And just coincidentally, there are 10 electrons here. Finally, what is the nuclear charge of the, what is the charge on the nucleus? What is the nuclear charge? Careful, it's not negative 2. That is the overall charge of the atom. Remember, the nuclear charge is the number of protons with a positive charge, because 8 protons have a total charge of positive 8, and that is the charge of the nucleus. Great. That's everything that I wanted to do. I have 30 seconds left, so I can slowly say to you goodbye. Thank you for watching the third lesson. See you on lesson number 4.